The James Webb Space Telescope has recently transmitted an extraordinary message, leaving NASA scientists completely amazed. As the leading optical telescope in space, it has been examining various sections of our vast cosmos for an extended period, uncovering numerous peculiarities. However, the latest image it sent has shaken the world of science and astronomy. What captivating image has the James Webb Telescope captured? Could it have possibly photographed an extraterrestrial craft on the farthest edges of space? Join us as we delve into these mysterious new images. The James Webb has revealed images that were previously unseen. If you want to stay fully informed about updates on the universe and its environmental elements, make sure to subscribe to our channel, give this video a thumbs up, and activate notifications. NASA's $10 billion James Webb Space Telescope was launched from the European spaceport in French Guiana. Upon reaching its extraordinary new destination, this infrared observatory provided astonishing views of the cosmos to researchers and astronomers. As the most sophisticated and largest space telescope to date, scientists were eager to analyze the first scientific images captured by the telescope. What they discovered nearly left them speechless. When the James Webb directed its instruments toward the famous pillars of creation, it captured the iconic dust clouds in unparalleled detail. These pillars, located in the Serpent constellation, are about 7,000 light-years away from Earth. The pillars of creation are part of the Eagle Nebula, vast clouds of gas and dust that were initially imaged by the Hubble Space Telescope in 1995. Since then, the brilliant glow of the tips of the pillars has been visible. The latest photo captured by the James Webb reveals the pillars of creation with much more intricate detail. Several stars are visible that were not apparent in the previous Hubble image, some of which formed millions of years ago. This marks a major leap in scientific knowledge. Additionally, the James Webb Space Telescope has scrutinized a region called Pandora's Cluster, capturing a breathtaking image named after Greek mythology. Pandora's Cluster is a section of space that was theorized by Albert Einstein in 1952. These new images have astonished researchers as they unveil unknown aspects of this area of space. It's important to note, however, that this region has an official name, SMX0723, which belongs to Pandora's Cluster. This cluster contains a blend of unique structures. What makes this image particularly interesting is that while it has been observed before, only the central part of this region had been analyzed by the Hubble Space Telescope. This suggests that there are still astronomical wonders yet to be uncovered in this captivating area of space, until the James Webb focused its advanced infrared technology on the region to examine and map Pandora's Cluster. The research team utilized the telescope's powerful instruments, including the near-infrared spectrograph and the near-infrared camera, as part of their deep observational program before capturing these remarkable ionotation images. They were merged into a comprehensive view. This sweeping image revealed roughly 5,000 infrared light sources within Pandora's Cluster, which is located approximately 3.5 billion light-years away. The image taken by the James Webb achieved an exceptional balance of depth and scope, potentially transforming our perspective on cosmic growth. A highlight of the image is a bright star at the forefront with its distinctive diffraction pattern created by the James Webb Space Telescope. Also visible are bright sources of white light surrounded by a dark aura, representing even more distant galaxies inside Pandora's Cluster. While human-made technology is crucial for exploring this galactic cluster, astronomers have also relied on a natural phenomenon predicted by Albert Einstein in his theory of gravity, known as general relativity, which he published in 1915. Furthermore, the continuous discoveries keep captivating scientists and space experts. The James Webb Telescope has captured unusual astronomical anomalies that even specialists cannot fully explain. One such enigma is the perplexing concentric rings observed around a distant star, a phenomenon that is still not entirely understood by space experts. The image was shared on Twitter by a scientist, sparking a flurry of comments and discussions among the online community. The picture displayed a star named W40 surrounded by typical wave-like circles that gradually faded. What stood out was that the circles were not entirely circular but had a somewhat square shape. This quickly led to speculation about a possible extraterrestrial origin. However, some experts argued that it was merely nature behaving in a way that appeared extraordinary from a single perspective. Sometimes natural phenomena can seem dynamic from certain angles but have simple explanations. Yet the questions remain: why do they have that particular form and why do they appear so regular? These questions have left specialists like Mark McCann, an interdisciplinary scientist with the JWST science team, puzzled. He called the phenomenon astonishing. In a Twitter post, he explained that the sharp blue pattern is a remnant due to optical diffraction from the bright star W140 in the image. Nevertheless, he noted that the red twist is real and it represents a series of shells around WR140 in space. Although NASA is expected to provide an explanation soon, it is well known that young stars usually emit a blue light, while older stars shift to a redder hue as they consume their fuel and cool. Astronomers didn't expect to see ancient red stars in the early universe, for which the James Webb Telescope was designed. They also didn't anticipate discovering galaxies up to multiple times larger than the Sun. These red spots, revealed in the images captured by the James Webb Space Telescope, seem in all likelihood to be far more massive. According to Jan Kai, the most massive galaxy in their sample is estimated to be only 2 to 3 times smaller than the Milky Way. This discovery is surprising because galaxies of the size of the Milky Way were found when the universe was only 3% of its present age. Lear also stated that before astronomers begin altering cosmological theories to explain how such enormous galaxies form so rapidly after the Big Bang, they must ensure that the elusive red spots they are observing are not something else. Otherwise, alternative explanations would also demand groundbreaking ideas. For instance, stars in the early universe might have emitted light in unusual ways because of a lack of heavy elements, which aren't included in our models. The images that revealed these perplexing galaxies were taken by Webb's near-infrared camera as part of the large early release science program. The team plans to return soon to these galaxies and the SMX-0723 cluster to gather spectra of light from distant sources. Spectra analyze the observed light by breaking it down into frequencies, revealing the chemical and physical properties of the source. Remarkably, spectra also provide very precise distances to these objects. Lear emphasized that only a few months after Webb's team released the first observations, researchers are being forced to revise their theories about the early universe. Observing the early universe for the first time led to the discovery of something so astonishing that it challenges science itself, as it upends our understanding of galaxy formation. Another extraordinary image captured by the James Webb Space Telescope shows the phantom galaxy, which appears to be a whirlpool turning before our eyes. This new image, based on deep space data, highlights the dust paths of the galaxy NGC 6208, also known as M74. Due to its symmetric spiral shape, the phantom galaxy is of particular interest from a scientific standpoint because researchers believe there's a massive black hole at its center. While the phantom galaxy has been imaged several times before, including by space observatories like the Hubble Space Telescope and the Spitzer Space Telescope, Webb's images stand out because of the near-infrared light, which revealed vast dust clouds combined with the power of its incredible 18-segment hexagonal mirror. The James Webb Space Telescope has become one of the most ambitious projects in space exploration, continuing to astound scientists with its remarkable capabilities and discoveries. Launched with the mission to uncover the most profound mysteries of the cosmos, Webb has lived up to its expectations in its initial observations. From capturing the intricate details of distant galaxies to revealing previously hidden cosmic oddities, Webb's contributions to space science are rewriting textbooks. One of the telescope's most outstanding achievements is its ability to peer deeper into space than any other instrument before it. By utilizing its advanced infrared technology and a massive 18-segment mirror, Webb has opened a new era of exploration. Unlike its predecessor, the Hubble Space Telescope, which primarily operated in the visible and ultraviolet spectra, Webb's infrared capabilities allow it to penetrate vast dust clouds and observe celestial objects that are hidden from optical telescopes. This ability has been crucial in observing the famous pillars of creation within the Eagle Nebula, where new stars are born. Webb's infrared view uncovered unprecedented details of these giant gas and dust regions, offering clearer insights into the processes of stellar birth and evolution. Furthermore, Webb's observations of galaxy clusters like SMX-0723 and Pandora's cluster have provided fresh perspectives on the large-scale structure of the universe. By capturing thousands of infrared sources within these clusters, Webb has enabled astronomers to study the growth and evolution of galaxies over cosmic time. The deep field images obtained by Webb not only enhance our understanding of galaxy cluster dynamics but also challenge existing models of cosmic structure and evolution. One of Webb's most fascinating revelations is the discovery of ancient galaxies that defy traditional cosmological theories. These galaxies, seen when the universe was still in its infancy, have masses that rival or even exceed that of the Milky Way. Such findings raise important questions about how galaxies formed and developed in the early universe. The James Webb Space Telescope has quickly become a central player in cosmic exploration, significantly advancing our understanding of the cosmos. One of its most remarkable achievements is its ability to capture light from some of the earliest galaxies in the universe, made possible by Webb's advanced infrared technology. Webb's observations have provided new insights into the formation and evolution of these ancient galaxies, deepening our understanding of the early universe. Recent images from Webb have shown galaxies in various stages of evolution, including intricate details of early galaxy mergers, where galaxies collide and interact. These mergers are key events in the life cycle of galaxies, influencing their structure and star formation rates. The telescope's detailed observations of these processes are helping scientists piece together the history of galaxy evolution, offering a glimpse into how galaxies like our own Milky Way might have evolved over billions of years. In addition to its study of distant galaxies, Webb has also focused on nearby celestial objects, such as star-forming regions within our own galaxy. Its ability to see through thick interstellar dust has allowed astronomers to study the birth and development of stars in extraordinary detail. For instance, Webb has provided new perspectives of regions like the Orion Nebula, one of the closest and most active star-forming regions to Earth. These observations are aiding scientists in understanding the complex processes involved in stellar birth and the formation of planetary systems. Another key area of research facilitated by Webb is the study of exoplanets. The telescope's infrared capabilities are ideal for analyzing the atmospheres of exoplanets, allowing researchers to detect and characterize their compositions. Webb has already begun investigating the atmospheres of several exoplanets, providing crucial data on their temperature, atmospheric composition, and potential signs of habitability. This information is essential for identifying planets that could support life and understanding the conditions that may affect distant worlds. The James Webb Space Telescope, with its unmatched capabilities, is unveiling details of the universe that were previously beyond our reach. Its remarkable infrared technology allows it to see through massive cosmic dust clouds, capturing phenomena that would have been invisible to earlier telescopes like Hubble. This ability is particularly crucial when observing regions of space where new stars are being born or where galaxies are in their early stages of formation. The insights gained from Webb's observations promise to reshape our understanding of the cosmos, pushing the boundaries of what we know about galactic evolution and the birth of celestial bodies. One of the most groundbreaking discoveries made by the James Webb Space Telescope is its ability to capture images of galaxies that existed when the universe was still in its infancy, just a few 100 million years after the Big Bang. These galaxies, often much larger and more complex than scientists had expected, challenge long-standing theories about galaxy formation.